So we're going to kick it off and start from the bottom and go up because the Avengers have got the call, so one of them has to go to the airport. So with that, first of all, I would like to say a big round of applause for all of you guys. And everyone is a winner, but today there will be people leaving with prizes, and that's not everyone. So, so with that said, Team Avenger, if you want to go ahead and come on up, and then this thing moves, so feel free to take it away.
Is everything on the screen?
It's clipping. I can switch for resolution.
Oh, that's all right. It's on. It's all on. Okay. All right. So we are the Avengers, and our project is called Fusion. And hopefully we'll reveal why we're calling this project Project Fusion as we get started. So first of all, to introduce ourselves, we have 3 people from Assemble. Do you want to forward the slide? Thanks. My name is Nancy Brown. I'm a national account manager with Assemble and also an architect. I'm based here in the state of Washington in Spokane, and I've worked in the technology industry for the past 8 years. So I transitioned out of practicing architecture on a day-to-day basis and into the practice of software technology with Autodesk, and then transitioned to Assemble just a couple of years ago. And with me today is Jason Jackson. Jason is a senior software engineer with Assemble, and Quentin Davis, also senior software engineer with Assemble. And with us from New York City is Amir Tasbihi. Amir is a senior BIM manager and project control specialist with STV Group based in New York City. Forward. So the problem that we are trying to solve today is a problem that many of our customers have, actually. And that is that there are a number of efficiencies in construction delivery based on isolated islands of information. So the construction management process has various knowledge areas, and those knowledge areas generate different work processes and also different activities that reside within different software programs. And those software programs very oftentimes don't integrate, don't talk to one another, which makes it also very difficult for collaboration to happen. So those discrete islands of information don't talk to one another, and certainly they don't integrate with BIM. And so BIM, very oftentimes, after the pre-construction process, is sort of thrown out. It's not leveraged or utilized further downstream into the construction delivery process. So that is a problem that we at Assemble are always trying to solve, but it's also part of the context for our hack today. Who has this problem? Well, number one, owners are really challenged by this problem. They obviously want the best possible product for the least amount of money, and the efficiencies in delivery directly impact their bottom line. It also impacts the construction industry and also impacts software developers and vendors. So that's obviously a problem that we're trying to solve. Why are we trying to solve this problem? Well, From the perspective of BIM, we're trying to ensure that BIM is actually leveraged for the robust data that it has in it. And we're trying to integrate that data from other areas into BIM too, so that it can be leveraged throughout this process. And the best person to create a problem statement for us is one of our customers. So I'm going to turn it over to Amir, who is going to speak to particular context for our hack today.
Thank you. Let me start with just introducing a little bit about, talking about a little bit about STV. So STV is a full-service company working in different areas, including construction management, design, building facilities, transportation infrastructure, and we have around 1,500 employees with different offices around the country. And what I can say is that when we talk about the islands of information, we are talking about ourselves. We are talking about us. We are the ones who are stuck in those basically islands of information. And what we have been looking for is basically we have a lot of data, and we have been doing this job for a very long time. Like our company has been active for more than 100 years, and we have a lot of data. We have a lot of expertise. But the thing is, all of that data cannot be efficiently integrated. A lot of the people that we know in construction industry, from the owners, from the different parties, they don't have efficient access to the data. And what we see, the trends that we are seeing in the market is a lot of people, because the companies like us are not seeing their needs, our needs being addressed through the software companies and different things. A lot of companies are starting to have R&D, and they are doing their own integrations and those kinds of things, and which seems to be reasonable. And this is exactly what we are doing in order to integrate the different packages. Can you go to the next slide? And what we needed to have, and what the need that we have felt through the years has been a software that should be that is cloud-based, because we need to. I don't need to have something like a desktop application, and I want to talk to the owner, say open Revit or open the other software or all the different applications, and go to that menu and do this and do that. It would be a little bit too complicated for a lot of the people, a lot of folks in the construction industry. They don't have that expertise. So what we have to do is to have some sort of cloud solution. I will give them a user and password. They would go on the website, and they will navigate through the model and do a lot of things. This is basically what we use Assemble in some of the use cases. We need to have access to, we have a lot of the different software packages like P6 and cost estimation software and all of these different things, but everything has to be integrated with BIM for us. And the most important thing is we needed something to enable us to do our integration. We don't need another software. It's just something that we thought might be doable with what Assemble has. We need something to enable us or other software developers to work around and do something around those kinds of components. And I think we thought maybe Assemble has a lot of the things, but if some things are done, it could open a broad area for us. That's why we work with Assemble. And for the first step, we thought that might be a good concept, but for the first step, we started from schedule, which is the most critical point maybe in anything in project management, because when you have a schedule, then you have costs, you have a lot of different things that are somehow attached to the schedule. We can bring all of that data into the BIM environment, like the critical path, color coding for critical paths, like the look-ahead schedules that we have in construction, like the 4D simulation that we do in other software packages. But if that is done through the web, then a lot of other people can go and see the project for themselves. They can go back and forth in time and see the project and how it is constructed and see the critical path, what objects are in the critical path, and things like that on the web. And eventually, what we were supposed to do was to compare planned versus actual schedules we get in a meaningful manner. And a lot of more people, not just the tech-savvy people, should have access to that data. Now, I will let Quentin talk about the details of how this was made possible in this hack.
The first detail was magic. So a lot of the times, you'll see products like Google Maps and things like that where they have their data up in their cloud, and you're like, oh, this is a really awesome map. I'd really like to use that. That was totally the wrong time. But a lot of times you see things like Google Maps, right, where you're like, oh, I love this map. I'd really like to use that. And people like Google, they made it available, so then you can embed it in your web page, and then you can put layers on it, do other things with the map, and that sort of thing. And folks like Amir, one of our customers, he had a need where he saw lots of different pieces of data that they had, and like, oh, I'd totally like to be able to take that data, combine it with this data, and put it over here on this web page. So what we did was he had Primavera where they had scheduling information, and then he saw the 3D model viewer that we had where they had uploaded their Revit models. He said, I'd totally like to take both of those and put those together, but at the time it wasn't very easy. So that's what happened this weekend was we took both of those pieces of data and we combined them into a third piece or a third application. By part of it was we had to first unbundle some of the stuff from our product so that we could embed it into something for folks like him and pull the data out of Primavera. So go to the next slide. To do that, this is one of the bonus points. For this, we started out, the WebGL view that we have, the architectural model viewer, is built in WebGL. The whole product is obviously HTML5, or not obviously, but it is. And during the hack, what we did in building the standalone web page that integrated our viewer along with the Primavera data, we frequently were running into various problems, so we wanted to just look out on the web, find whatever open source projects we could that we could pull in to quickly do something and that sort of thing. So we use a lot of the obvious sort of things like jQuery. A lot of people use jQuery for DOM manipulation. We had Backbone and Slick Grid. Slick Grid's not necessarily obvious, but we had to have a grid. Slick Grid's really great. It's very slick. Obviously, we're using REST to make calls back to get the data. We were like, oh, we wanted to show some scheduling. As Amir was alluding to, we wanted to be able to see the model change over time and that sort of thing. We said we'd like to have a slider. We went out and looked on the web, found a really great slider called JQ Range Slider, which was really awesome. It looks very attractive. You throw that in there, and it made a lot of things very easy. And we had other little problems where we're pulling in the date from Primavera, and the date times that were inside of Primavera weren't easily parsable by the engine that is used inside of JavaScript. So we used that, and it helped parse the data. So we'll go ahead and, did you have anything else, or we go to the demo? Okay, let's go ahead and go to the demo.
So as Quentin described, I mean, one of the key things that we did here was allow the model viewer to be embeddable, which means that our customers, such as STV or other customers or other software companies, can actually embed the viewer to connect with any kind of data source that they wanted, so or that you want to connect to. So in this case, we chose to use the data source from Primavera because it's very robust, a lot of data. As Quentin referred to, it's got tasks with the beginning start date, actual start date, actual finish, budget, etc. So we pulled in the data that we thought would be useful for the prototype. In this case, we've got the activity ID, whether it's critical or not, activity name, start, finish date, budget, the selection, so selection in terms of number of components that are selected and assigned to that activity, and then various, and then being able to assign the components. So the key part is being able to, or the first part was being able to select components on, from the viewer. So Jason is actually going through, selecting the components, assigning them to a particular task, and then they are color-coded based on whether they are critical or whether they're non-critical. And so various objects can be assigned to various components based on where they're supposed to be in the schedule. You'll notice that it's kind of dark with the background screen, but he is just going through and clicking. So we're making a call to the mobile, to the viewer app, and enabling that interaction with the 3D model. So this obviously doesn't require any modeling skills. Somebody doesn't have to know how to model, know how to use Revit, know how to use AutoCAD to be able to do this. They can simply be sitting at their web page on their laptop and be applying the tasks to the modeling components. Did I miss anything? Oh, the next aspect.
And I guess it's not real obvious because it's a little bit washed out here, but we're showing the critical items in an off red, and then just the other items kind of in just a little bit of a shaded model color.
That's right, and then the components that are gray are those components that have not yet been assigned to an activity. So there is a way of, and they're automatically being color coded by whether they're critical, non-critical, or unassigned. So go ahead and move into the simulation. Now, in addition, additional criteria for STV was to be able to show the objects over time, obviously in simulation. So you see the slider bar at the top, which has 2 dates and 2 ranges. So you can either show a time period and what is happening during that time period, or you can show the accumulation of activity over time.
And you can't see it on the washed out screen, but the whole building is here ghosted. You know, if we were in a dark room, you'd see that the whole building is actually there, so you have context for these things that are just kind of magically appearing in thin air.
And it's full screen. So notice that the grid has disappeared, it's full screen, and you're interacting with it dynamically over time. So with that, any last comments, Amir?
So just one comment, which is, so basically this has what is known as 4D modeling, fully on the web, without any need of any desktop application. And not only that, you can actually simulate the critical path. And other than that, actually the slider that you see on the top, you can view the look-aheads, so you can actually play with the range of the data that you have, and you know what activities are happening within that range. And also you can go back and forth in time to view the 4D simulation. So it has 2 functionalities in one viewer, fully on the web. And the other thing that I just wanted to mention was the viewer component is so optimized because there are a lot of viewers on the web, and some of them free, some of them whatever. But not all of them, I think a very limited few of them can handle huge models, sophisticated models. This is one thing that we have tested. That's why we were interested in this, because this works with really significant type of models. So when you have a lot of elements, it works well. So that's another point that I just wanted to add.
So for the future, we didn't get to driving the activities with the Assemble quantity engine. We have, we pull all the data from the models, and so the next step for us is really to add the quantities and cost, which is data that we have. We just didn't get time to integrate it into this process. So we're really excited for the next steps with this, and we're really excited that we've been able to decouple, or what I'm calling disassemble, assemble, so that we can actually allow others to engage their data sets with us and take this even further. So thank you.
Awesome demo. Okay, and then just to say, as y'all can kind of tell, it's hard to see this stuff, so I will ask those that have presentations after all the presentations have gone through, for those running examples, if you can just keep those running so that way we can have the judges take a look at them and see them, and you guys get full glory. So what we're probably going to do is this next team sets up one. Yes, one of the people over there brought up mic lesson. Have it close to your mouth. You don't have to make out with it, but just have it closer to your mouth. That'd be great. So we can hear you, because I don't know how the microphones are back there. And are you guys good? Okay. And then what we'll probably end up doing is just take a break somewhere in between 4 and 5, so people can stretch their legs, use the restroom, that kind of thing. So. But again, your laptops have to stay in here, so. Awesome. And Team Carnegie. You guys ready, Stefan?
Hey everybody, I'm Stefan, and little did my team know, but I came up with a name that they weren't expecting. But if you're a nerd and a history buff like me, you probably like Andrew Carnegie. Obviously, the invention of steel led to an entirely new kind of development of buildings and skyscrapers and higher density cities all over the United States. So that's just my little quirky name for our team. But you can see I'm the founder and my partner here of a company called Create, and we used actually our software as a service platform as one of the technology components that we worked with today. So you'll be seeing some of that. You can see it on the bottom here. This is a 3D GIS map with land use of every building in DC. This particular picture has a heat map of where all the retail density in the city is built out. So you'll see bits and pieces of that.
We had an awesome team that we somehow wrangled and convinced to work with us, which I guess was about 12 people. So big shout outs to Melissa, Devin, Andrew, Susan, Sabi, Sean, Dan, and then the folks from my staff, John, Vanessa, Laura, and myself. So what our objective was to try and figure out a way that folks like myself, and my background is in real estate development, so I'm not an architect or a contractor, but I'm more on the owner-developer side, and I was constantly faced with these challenges like, okay, well, we have a site, then we need to figure out what the heck do we do with it in order to maximize the value, or we have a client and they need to build a hotel and figure out like which site in the city and there's 138,000 individual parcels in Washington, D.C., can we site that building on in order to maximize their ROI and achieve all the rest of their business goals and reach an achievable building program. So we actually, this is hard to see, but I mean, we're really trying to get to the processing of not only GIS data, but also different kinds of business requirements that we can generate, as well as constraints based on form-based code, primarily from the zoning side, not on the building code side just yet, to reach an instant indication of design feasibility. So for any site in the city, how can I really just instantly generate a massing model that would give me some indication as to what my yield would be? And so what we initially started to do is, if anyone here has used the Unuma planning system, that was the technology where we're going to integrate and do some web service calls to try and just send out our requirements and then pull back in some, leverage that procedural generation and then pull back in the 3D building geometries and then superimpose it on our map. And really, if you've seen or used this stuff, you can see it in the top right here. It will generate an actual 3D stacking model and get it on our virtual globe in order to reflect that real-world position. And on the bottom right here, we had this whole big convoluted list of steps that we needed to do in order to try and wrangle the data between these two different sources and then kind of end up with the end result that we wanted. Well, unfortunately, we had some issues. So I was actually pretty happy because it took us only a few hours to figure out that this was not going to be the solution for us. So much credit to the team because we actually had about half the time because we had to start from scratch at about 2 p.m. yesterday in order to figure out what the heck it is what we're going to do. And really, through the course of our software development, we realized that we really don't like Google Earth. We think that plugins are going the way of the dodo bird, which you can see in the top right. And we ran into some other issues as far as the inconsistency between the programmatic building inputs and then with the building geometries that we would get back, it was really incomplete. We wouldn't get all of the information that we would need in a collada file if you are familiar with the GIS world. And obviously having to cope and deal with a lot of third-party proprietary technology was a little bit difficult for us to adapt. So we decided to say, well, screw it, let's throw it out and roll our own and see what we come up with. So Christmas came early on the bottom right. You can see the 3D Santa superimposed on the cesium globe. And we kind of took a step back and looked at, what are the different levels of detail that we can, really need to step through and what requirements are needed at each level of detail in order to really kind of shepherd this through the whole process. So we looked at, okay, well, we have the building footprint, we have the lot footprints as a shape file, and we have a few different constraints, both lot occupancy and front and rear setback, or I'm sorry, rear and side setbacks. There's no front setbacks in Washington, D.C. And then we could also work in the building height and further down the line, the FAR, in order to reach a maximum development envelope. So we tried to kind of get as far down the line with the first step over here on the left that we could, and then we're working towards really getting a massing study that you're seeing as we kind of get a little bit more refined as to how we determine this feasibility. We're not trying to go and process the entire form-based code and get into building codes and all that kind of stuff and do code checking. Not really our goal, but something that is, other people are fortunately taking on rather than us. So with our second attempt, what we did is we actually used a lot of the bundled tools that are built into the virtual globe that we're working with, which is Cesium.js, which is an open source virtual globe and a web-based version of Google Earth that is actually a lot easier to work with, assuming you don't have an Intel graphics card, and actually write our own scripts for computational geometry to process that information and then work with the both X, Y, and Z axes through our GIS data to basically put the framework in place for automated building geometry, but allow users to go in and augment it so that if they wanted to, basically ignore a zoning rule. Well, we can allow them to do that, and then the logic in our system down the line will go in and basically tell them, hey, if you want a zoning variance, I mean, good luck. It's going to take you 6 months and cost you $100,000 in legal fees, and even then it's a 50-50 chance you're actually getting anything done. So here's kind of what we came up with, and we can, there's a couple screenshots, and Laura will show you the live version in just a second. But what you're seeing here is a neighborhood in DC, and this white parcel is actually our other partner's house. And we have a list of all these different rooms and things like that, but really what we're more focused on here is the XY coordinates of each of the vertices of that lot. And with a simple click of a build button, we have generated a wonderful looking purple building that is a potential skyscraper that could go on that site. I guess not a skyscraper in DC.
A 4-story.
4-story row house, as opposed to a 2-story row house. So we can actually, we've taken all those rules and we said, okay, well, this lot is shaped like this, but that geometry also has an R4 zone attached to it. So what does the R4 zone mean? Well, it means that you've got to contend with all these different constraints. And as a result, if you wanted to build out to the maximum density on that site, voila, one click, and that is the building model that you end up with. So Laura, why don't you take it away?
Okay. Hang on while I connect up. If you want to disconnect, that might help. Let's see if I can get my monitor up there. Okay. So, this is in many ways the kind of the rough sketch of where we're going. And, we had big dreams for Enuma, but we're really excited actually to just bring this into Cesium and own it. And so when we click on a building, and I'll just give you an idea of what our software does in a more general kind of way, you get like a whole lot of detail about that property. And so this is the detail that we'll be harvesting in order to figure out what kind of building can go on there, how big it can be, what the zoning rules are. And so, we sort of have this basic construct that we'll be able to work from as we develop this module. And I am not seeing something here. Hang on one second. One second, bear with me. Where did my menu item go? I'm just gonna hit a refresh here and back out for a second. So, this was working 5 minutes ago. Hang on a second. Code is good and running, and let's see what a refresh brings us. I have no idea where that went. You want to say something? Okay, so the other things, some other things that we're doing, I'll hem and haw here. Some other things that we're doing that are really close, we're looking into more the financial analysis side in what you can put at in a property and profit predictions. Stefan, I'm going to give this to you while I reload this and make sure what was working 5 minutes ago comes up. And no, I've got internet. We wouldn't have buildings if we didn't have internet. I just need that menu item to come up so that I can actually. There it is. Okay. Oh, I know, because I clicked onto the other menu. Pardon me. Okay. So here we go. Okay, let's go. Let the buildings come back. And we're going to do just a little movement here so we can see it better. Okay. So, and zoom in a bit. Sorry about that. Yeah, I haven't sent it to QA yet, so, All right, so we've clicked on this property, and now we're at 3507T, and we're We're going to drop this high-rise right on top of Ed's house. There we go, and we have a little commenting here just so we see it's happening. And bear with me. Okay, it's going to do a little refresh because I did zoom in. There's our high-rise. Okay.
Voila, there it is.
For DC, that's a big building, so there you go.
That's one of the bigger, taller buildings in DC. But I mean, the concept here is that not only can we do this for one building, but we can do this for every lot in the entire city. We can do this for every zoning condition, if you want to do a planned unit development versus a simple variance, existing conditions, whatever it might be. This can be really extrapolated across all 100,000 plus lots in the city. So DC is one thing, it's pretty built out, but one of the places that we're looking at going next is Detroit. So you can imagine that it would be really interesting to see the entire city built out. I don't even want to imagine how many lots and just the amount of land area we'll need to cover with this kind of stuff. But that's it. So.
All right, thank you.
Great work, Stefan and guys. Guys and gals for y'all's team. Okay, so next up we have Air BIM. Awesome. Somewhere here, and she has more cards. So, yeah, just please, guys, we definitely want to give your stuff justice. So, if you can do a screen grab and whatnot, and then you ready to go? Okay, now we're kicking it off with Air BIM.
Hi, my name is Willard Williams, and I'm an architect. And so what I wanted to show is kind of multiple dimensional representations of BIM models. So currently, the software that I use in most software have a model and plan viewer that is, this is BIMX Docs. So it allows you to look at the sections and plans of the construction documents. And it's pretty interesting because you can look at the documents on the plan, but again, it's like on this little small tablet. So I asked the team at the Smartboard to help me port it to their board. So we're running a Android device on the Smartboard through Windows 8, I believe. So this is BIMX Docs. So this is the same software that's running on that device, but it's just been ported to run on this larger Smartboard. And so this is a pretty amazing solution, in my opinion, just to port it out. So you can look at your plans, and then you can go back to 3D. So it shows the whole thing. This is a little graphics card error. So you can go into the model, and you can change the section cut. Let's see here. So now we're looking at the section, and then you can go, I guess, back to 3D, and let's see here. Actually, probably needed a little bit of assistance. Here we see. So you can move these section markers, and you can cut through the building, and you can, oops. So, and then you can also walk around in the building. Oops. It's a little hard with one hand. It's actually probably better with two. Okay. So, and then what this allows you also to do is to mark up the plans. Whoops. Hold on just a sec. So I could mark this up if the graphics card was okay, and then I could make a note, you know, adjust. And then I could, if I could get it to not black out, well, you get send a PDF of that? Okay, perfect. So now I'm able to adjust I'm able to send this to somebody in real time. So, okay, so that's the smartboard. And now, yeah, hold on just a sec. Okay, so on the VR cave, I wanted to be able to show the elevations of each of the sides of the buildings in real time, so you would be able to be inside the building. And I don't know if it's up and running yet. I give him a pretty big model and a little bit late. So, can you walk around? Okay. So maybe somebody over there can put the VR glasses on and walk around real quick in the model. And the goal with this would be to edit within the model real time and send it back to the BIM model. So in theory, you'd be able to do that in one plane and then this in another and be able to see the two sort of connected. Hopefully that works a little bit more smoothly. And I can show you kind of what the model that it's based off of. Let's see here. So this is the, can you hold this again? Yeah. So this is the model that he's looking at. It's building, okay. So I'll just show you what he's looking at. So this is just a residential house in Redwood City. And each of these elevations represents the opposite. So you're looking at that building elevation on this side. You're looking at this building's elevation on this side. And then this side is looking at the garage, which the garage is right here. So, and then you would be able to walk around the model. And if you were adjusting something, you would be able to select that window or that door and adjust it and watch the elevation change. So if he can land on the ground somehow, maybe not. There you go. Now crawl around. So that would be the goal. How's he doing? Just crawl on your knees a little bit. Look up, look up. There you go. Perfect. So that's the intent, is to be able to look at the elevation, select a door or window, adjust it in that situation, and then be back here and see it in BIMX. So that's kind of the AirBIM concept, and thank you for your time.
Awesome. Nice work, Willard, and thank you, David, for audience participation. So this is going to be up here and then over there. So it looks like we're ready. So Project Face 1.2, take it away.
Thank you very much. Just a second, I'm tweeting this. I think that 2 of my 7 followers are in the audience, though. So let me get over to my command center. Here we go. All right, so we are Project Face 1.2. Why 1.2? Because we did Project Face at the last one, and we decided to do an evolution of what we did prior, rather than try to reinvent the wheel and go with something else. So I'll get to our team here in a little bit, but For those that were around Friday night, you might have, or was it Saturday morning? It's a blur. I had a gripe about file sizes, so I wanted to quickly do a little bit of research and show a little, well, first of all, I've got some boilerplate. We won't go through that. It basically says the URL accomplishes and the copyright infringements that you're about to witness. So there's some challenges in manipulating BIM models for something other than what Navisworks wants to do, or Revit. And those challenges are that the geometry that comes out of this authoring software, that's basically a database that can render the geometry in place, comes out as triangles. And I wanted to kind of show you a comparison of what happens when you create triangles versus when you create objects that are instanced using modern instancing technology and 3D software. So it's hard to see the one on the right because the interface is pretty dark, but basically what I did is I went into Revit and I created a 50-story building, just the windows, just a curtain wall system with some mullions. There's about 3,000 mullions in this. And then I went to Cinema 4D and I did the exact same thing with parametric objects using instancing. Very simple little exercise. So a little something about file sizes. Revit file with this amount of stuff in it, about 3 megabytes. You know, Revit's got a bunch of other stuff in it. I purged it so that it didn't have any families that I wasn't using, things like that. But there's a lot of data in there, right? So it's understandable. There's about 3 megabytes. IFC, not the cleanest file format. It's 18 megabytes. But that still carries a lot of information. But when you want to take it out to a place like Unity so that the VR design guys can deal with it, or you want to take it out to Cinema 4D, or you want to take it out to 3D Studio Max to make some renderings, using FBX, you're still at 7.4 megabytes, and that's just geometry. If you're using instancing technology in something like C4D, we're 192 KB, not MB, KB. It takes 1,000 of those to get you 1 MB. Just a little lesson for those of you that are a little bit young in the audience and have never used a floppy disk. That would fit. So I decided that was not really all that fair. So I went in and I took my geometry and I added all the complexity that mullions have with reveals and channels and slots for the glass and stuff like that. I brought it up to a whopping 213 KB. So instancing technology, guys, let's use it. Anyway, that's my gripe. But why do we want to get out of Navisworks? Why do we want to get out of Revit? You know, there's a whole ecosystem out there of solutions. And quite frankly, there's a whole bunch of people out there that are using that ecosystem of solutions. And the real benefit to BIM is the collaboration that you get with it. That's a picture of a bunch of people in a war room, quite frankly, and it's kind of hard to see, but that's what it is. So that's why we want to do that. That's why we want to get out of the 18 megabyte files, so that we can do this kind of stuff in that ecosystem, in that environment. So a little bit of background at the last AEC Hackathon. We kind of had this gripe, if you will. This time it's file sizes. Back then it's like, hey, wait a minute. I use Pinterest and create a board, pin anything on the web, go back later. I use it when I travel, pin restaurants and locations and places that I want to go check out and the places that I'm going to. And then I get there and I have them at my fingertips. Use Facebook. Get together with my buddies. We go fishing on the Columbia one weekend. We get home, we all share videos and photos. How is it so easy? And then I get to work on Monday morning, I gotta check my email and see what's in there, and see what attachment people have sent me, or see what link to what download to. It's too hard. So last time we decided that we'd assemble a crack team from around the globe, and in this case we actually truly have a global team here. We've actually gone around the world. We've got myself, I'm originally from Spain, so I threw it in there even though I'm here. It doesn't really count. David Diarza. Vishal Purwal is from India, so you can throw it on there. Leon van Berlo and his crack team of Open BIM folks in the Netherlands today helped us out, and we're very gracious. And then we've got the team from VRcade, Dave, Jamie, and Ivan helped us, and we're very, very grateful. So we're going to get to that stuff, which is the fun stuff here, pretty quick. But a little bit of background. We created a Facebook-like timeline for collaboration online that you can add models to and basically manipulate models inside of this interface and also annotate. And I'm going to do that right now. Let me just jump into the model here. Oh, great, that's not gonna, it's gonna take a little bit to load. So while that loads, we're gonna show you the other piece of this. So while this loads, actually it might be pretty quick. So basically what we've got is an IFC file, again, heavyweight, so there's some limitations. So we've just got one particular part of our scope over here. This is the model. We can click anywhere. We can tell it whether it's complete, not complete, in progress, tied to 4D data. Very simple interface like we saw earlier another team do. We also have the ability to create viewports that then allow us to basically annotate and mark up on top of the model. But we have this tool over here, this toy, that is absolutely wonderful. So we said, yeah, this is all great. Let's go play with this. So let's check out what these guys are doing. We've taken the same model and we've thrown it over here in Unity, and our Jamie's our friendly MEP engineer, and he's going to check out some of the clashes that are going on in this. So I hope that you can all see the screen. Basically, he's inside the model, he's looking around, he sees some of the pipings in the wrong place. Well, right now, and this is the part that's still under development, I would be able to basically comment on this model, and he has a interface panel in his VR headset that is showing him a heads-up display of whatever we're typing. Not only that, but he can mark up this model, and it's a little rudimentary right now. We're using a technology called screen capture. We are basically creating a screenshot of what he's doing there, and it's being uploaded to our comments here on the viewports. So our intention with this is to bring, whether that be in the office, at the studio where the VR immersive display system is, or whether it be at their computer, we can have an immersive session for clash detection, for collaboration. Because quite frankly, when I drive a Navisworks session, you know, everybody's following me around and tell me, no, look to the left, look to the right. What I really want is for the structural engineer and the electrical subcontractor, they see a clash that's relevant to them and they walk off from where we're at. And they go discuss that in isolation while the rest of the team does something else. So real-time, collaborative, immersive coordination. That's it.
Job site tool inventory management with RFID tags. Our name of our team is Dude, Where's My Nail Gun? So on our team today, my name's Neil Gordon. I'm with Mortensen Construction, and Brian.
I'm an architect here in Seattle with Via Architecture.
Trung?
James Moore,
Okay.
that's a developer at Digium. And I'm a basic student development.
So we all met first thing Saturday morning, didn't know each other. Got a couple of software guys, a couple of AEC guys, and we came together to try to solve our problem, and I think we came up with a pretty good solution. So when we approached our problem, at Mortensen, we really have an initiative to do lean construction or lean tools in general. So what we did is Brian and I went in the other room while they were doing the coding, which we really couldn't help with. And started to try to lay out, you know, what it is that we're really trying to identify. What is the waste? What is the room for improvements and such? So we laid out, and you can see we had 25 different tasks on a typical 2-day kind of tool hunt and what it takes and how it all comes together. And then we went back and identified all the different types of waste and then other tasks that we could see that this tool would make improvements on. So from there, we kind of laid it out to try to give you an idea of what it is. And so in the Mortensen Seattle company, we have 10,000 tools in our yard, for example. On the project I'm currently on, there's 180 people on the job, 8 crews, 1 Connex per crew, 250 pull Connex. As you can see, it just gets bigger and bigger and bigger, and it's a huge job just to try to manage all of that stuff. A lot of expensive tools, from jackhammers to sawzalls, and you can just imagine the tools it takes to build a project. So after that, we kind of identified, you know, what is the true waste, and what can we really identify as opportunities to make it better. So lost productivity, walking around searching. You can imagine a guy gets out in the morning, he goes to put his tools together, and notices his gun's missing from the night before. He didn't notice the night before, so he goes out, and then now he's got to track down where's that tool. So he's walking the site trying to find it. To start with, we got list. The superintendent creates a list for the tools he needs. He sends it to the yard. The yard takes that list, compares it to their list, and marks off all their stuff. That list, now there's 2 lists, and then there's 3 lists when it comes back for the guy that's managing the tools to manage that list to confirm he got all the parts. So list upon list upon list, it just gives opportunity for lost data. And then there's the lost tool, of course, which can always be a cost of the tool and loss of production time. And then the confusion between subcontractors. If anybody's been out on a site, there's 2, 3 different, 4 different subs all working in the same area, all using the typical types of tools. They lend tools, borrow tools. So, tools just end up being missing.
And then there's the confusion of,
yeah.
oh, I thought it was mine.
Yeah, I thought it was my tool. I'm sorry, confusion. So, the one thing I got from our yard before we started is he's kind of done an evaluation of what it is that they're trying to get rid of, and that's lost tools. 10,000 a year is right now. We got a number we know is true, that we use $10,000 in tools a year. And up to this point, all the solutions they looked at cost more than $10,000 a year, so they said, we'll just pay for the lost tools and move on. And, so that's their solution. But they never really calculated in the productivity. Again, like I talked about, the guy that's looking for his tool, he doesn't have his tool, he can't do his job, he has to wait for somebody to bring his tool. That guy that's bringing his tools could be doing something else besides bringing him a tool, and so on and so forth. So by doing RFID tagging and creating a master list from our yard, and using that list and then using that to tag the stuff so we know what tools are available, we know we're getting the right tool to the right person at the right place. Again, lean, that's what our goal is, and that's what we're really shooting for. So the concept of the RFID tool tracking is the tools would be scanned in the database. It would be our yard would create a database. They got to do inventory on every 6 months anyway, so one of the times they do it, they go out, tag, scan, and create the database. It would help keep log movements from the job back to the yard, that type of stuff. It would help with daily check-in, check-out. Imagine you have a scanner on a Connex. As you take the tools out, it would check them out. As you pull the tools back in, it would check them in. It would,
Connex is the big shipping container.
On a job site.
Yeah.
And then at the same time, with this tool and with the right kind of RFID tags, you can use the scanners to actually help find tools out on the job site. Again, instead of taking an hour or longer to try to find a tool, you might be able to use this. It's not going to find you exactly where that tool is, but it's going to narrow down that area to a point. It's going to take half the time to find that tool as it would have before. Then we'd have the mobile app for the foreman. At this point, we have one guy on our project, and his only job is tool logistics and material logistics. That's all he does all day, every day. And it's a pretty manual type of job. He has to go in and go through things, find out what's there. There's no real tool that we have that helps him be more efficient and be able to get his job done better. And then at the same time, it could report back to the yard, so the yard would know the night before that there's a missing tool or that they needed more inventory or there's a broken tool. They could better plan their guys who goes out to the sites every day and brings stuff to the site. He could better plan his day, better make sure he has the stuff he needs, and he can plan out his route so he's more efficient at the same time. Again, all of that could be savings. So we were able to get to show a basic demo, and Electron and James take over from here.
Small problem here, you have to read it backwards because of our camera.
You need the mic?
Flag if you can't hear us, but we have here the view of what's on the phone app. It is backwards because we don't have a flipping thing to make that work, and, well, you can see there are listed items. So the way that thing works is that we have in the box here a RFID reader. This is just a commodity RFID reader. It's off the shelf, came in a box. We implemented this with the API that comes with it to constantly read what items it can see nearby. So in the box, we got a hat. This would obviously be worn, though this one doesn't have the internal structure, so I might not wear it. We have a nail, not a nail gun, but it's the nail gun. We have another item and so forth. We've also tagged the bins, and the idea is that by having one of these either permanently allocated in a box or in a connex, you can sort of track the proximity of items. So if this thing is receiving signals indicating that it's near the hat, so are you able to show that?
Sorry, whoops.
Oh.
This is the expected list, so this is the inventory here. Here is the things we're detecting, which right now is just the hat that it's next to. Oh, sorry, that might be my fault. That's the hammer drill that's somewhere close to that reader. It's in my back pocket. Right, we're tracking our FFT tags that we've named tools. And so this is a list of the things that are missing, right? This is the delta between the things we have and the things we expect.
So the idea is that we're able to generate a constant stream of events telling us this thing was in proximity of this station with this person. And from that, you can start to develop information on who had it last, where was it seen last. So if an item is missing, you might be able to say, oh, it was last seen in the wrong box, and go pick it out of the wrong box. Or it was last seen in Bob's hands, and Bob was over there. So you can go check where Bob was. So it allows you to sort of get more information and make the process of finding things just a little bit easier.
Okay, we didn't mention the tool that we were going to lose in the demo. We had a grinder, a sawzall, you know, all sorts of regular items, and then there was the unobtainium smacker, which is very expensive. It's lost all the time, and no one knows what it looks like. So as an architect, what can I do? I can just make things look pretty, at the very least. So we also mapped out. We mapped out how, this is the proof of concept, how do you make use of this very basic information relative to a database that someone can access in their pocket. So we just really quickly mapped out how on a particular Connex box somewhere on the site there could be a number of these bins, and they'd all be identified, and in the morning they'd be loaded up. So bin 1 has 10 tools, and there's actually 10 tools in there right now because it's 3:55 p.m. I want to go home, but I have to find all the tools. Bin 2, it's missing 2 items, and everybody's looking good. Bin 6, there's 15 tools that should only have 9, so we're kind of wondering what's going on over there. So let's look at bin 2 to see what's happening, and we have sawzall, hammer drill, all those tools, batteries, and both grinders are missing. So, dude, where's my grinder? So let's look for one of them, and we hit the grinder, and we can see that it should be in bin A2, but it was last seen. It was actually read by the system, which is networked across the site. It was read by bin A6. So as we suspected, there's something funny going on in the back corner of the job site. It was checked out 7:53 in the morning by A. Kucher, so we know who to talk to, presumably with active RFID. These are passive tags with active reader and more power. You might know where that bin 6 is, and you can go over there, and if you can't find Mr. Kucher, you can at least hopefully find the grinder, get it back into place. And so we have a happy ending. So that's it.
All right, super cool stuff, guys. All right, so next up we have analyses. I'm not going to say. Do we have, Mark, do we have the HDMI in here? For an HDMI?
I think we had some of the power for.
Oh, all we have is VGA.
Only VGA?
Yeah.
We don't, none of us have, none of us.
Do you need to run it off of this view?
We don't, none of us.
Okay.
Should we go later on? Yeah, if you want to, you can go later on. Okay. We'll
On cable, okay. Okay, so actually next up is build track. Analyses is going later. So build track's up next. Or now, actually, I'm sorry. Build track's up now. It all depends on how these guys go. Okay. Yeah, man. Cool. I forgot how many of you guys were up in that room.
This mic isn't working for some reason, so I'm going wireless.
Okay, we're
You don't want to use this?
No, I do want to use that.
Okay, cool.
That's my primary. This is just to cover when people aren't talking to me.
Gotcha. And then if you get the hands up to finish your time, just try to wrap it up. I mean, you don't have to do a hard stop finish at least, but just speed it up. Those were not the droids you were looking for, right? That's not the way that's... That's an interesting example to use, yeah. Explain.
Good. All right. Well, we're Team Build Track. Let me go ahead and advance there. We came, I'm Michael D'Souza, so I'm from New Forma. I was at the first hackathon. I had a really great time. I'm very excited to be back here. This one's been even better. We've had a great team. In fact, probably the most nervous I've been is thinking about trying to pronounce everyone's name here. So I'm going to let them go ahead and do it real quick here because we don't have much time. We have a huge team. Go ahead.
I'm Jeff Rader. I'm a software developer at New Forma.
I'm Greg Mayer. I'm a software developer with New Forma. I'm Louis Martinez with Howard S. Wright.
Elizabeth Angel with Howard S. Wright.
Matheus Pedrosian from Microsoft.
Diana Alazarian with Howard S. Wright.
Chris Sweeney with Controls.
And Ryan Soul with Howard S. Wright.
All right. So when we came to the hackathon, we set a goal for ourselves. We wanted to build a complete software solution for a specific problem end to end in a single day and a half, which is a really tough thing to do, those of you that work in this industry on the software development side. And it's challenged even more by, sometimes we don't always speak the same language. We're talking with our teammates trying to understand the problem, and they did a really great job of explaining it, but we don't have that much time. So what we've done is put together a video to help explain the problem a little bit and how the solution is going to help. So can we go ahead with the video? Okay, so I'm going to bring up teammate Lewis. He's going to walk us through some of the problem that we set to solve, and after that we'll do a quick demo of the solution.
Okay, so the pain is that current production reporting at the work phase, so where the work is actually happening, it lacks a real-time accuracy. So that makes it difficult to identify job trends and to keep production rates concurrent with the project schedule. So this is a real pain that I felt before on projects, and then the other back-end problem is that you don't have the accurate historical data to move forward with the business. So who is this for? And I commend the last team as well, is we always have to remember in this industry that at the end of the day, what happens is these projects get built by people. And so empowering the people with tools is, I think, one of the most important things. Sometimes all you need is a hammer. You don't need a hammer with a knife, with a sawzall, all in one tool. So the idea is that it's a field supervisor, and he's the one that struggles with getting both the work done, getting the work in place, and tracking the metrics that a project manager needs to understand what's happening with the project. So we need real-time accurate data for those two reasons, project health and for data for future pursuits. So the why is we really want a user-friendly method. We want something that is very simple. We don't want something that's coupled with the estimating software. There's business reasons for doing that because you want to set goals for the project that help you to beat the budget and to beat the schedule. And it also needs to be simple because we need to be able to encourage adoption and embedment. So it's important that it's simple and easy to use, one-touch, two-touch, three-step processes, and it also has the ability for it to be set up on the front end so that what the person in the field is actually doing is saying, I'm this guy, this is where I was at, this is how long it took me, this is what I got done. He hits the button and walks away. So the impact, again, is financial. That's the main reason. It also has to do with incomplete work and profitability. So we pulled some metrics. So as a case study, we took a project, 14-story mixed use. You saw the video with the Benny Hill music. So cast in place concrete. There was, on these metrics that we would track production on, there's a pure labor overrun of 13% that we would attribute among the team from lack of tracking productivity, or things get coded to other items, or there's too many guys on the crew and they're just being carried and you don't really know. So there was an in-place cost of labor per cubic yard of 142 bucks. The budgeted cost was around 126. And we took some statistics from 2001 for just total in-place yards of concrete for multifamily high-rise, of which this was that project type, and then cast-in-place superstructure in general. Those are the total in-place yards. And we come up with, go ahead. So if we were to say, using an app like this could capture a third of those overruns, just a third. And then you could scale it in your mind if you thought it was less or you thought it was more. Just for those multifamily, that yardage from those multifamily projects, we're looking at $67 million. For superstructure overall, you're looking at $2.7 billion, making some suppositions that the cost rates are equal, the estimate rates are equal, and that the in-place rates are equal. As if we did all the projects, which would be great. So here's a chart that kind of gives you the magnitude of difference. So trying to affect the work in the industry at the work face with simple tools. And then Michael's going to take over and talk about what we actually built.
Stay up here and help us with the why as we go through it. So let's bring up the... Okay. All right, so this is the interface for the iPad app. So at its basic, it's a plan viewer with the ability to set up regions and assign, I'm going to mess up on the terminology here, work packages to each of those regions so that you can record progress as you make your way through. In this case, it's about concrete pours, right? So we go ahead and tap into one of... So here you have the regions already set up, and this is actually working. This is the iPad app. And as you tap on one of the regions, gray being something that hasn't begun yet, you have well, you can't really see it there, but you have a really simple interface where you're only asking two things: how many hours you just put in and the percent complete. Again, the idea is keep it simple and encourage adoption. One of the challenges that they've had, and I think many others have, is that we give these tools that are overly complex to the people in the field, and they have so much to do that they can't actually take the time to stop and do this. So really, from a software developer's standpoint, our job is to build the tools that help the project go and then get out of the way as fast as possible. They're not getting paid to use our tools, they're getting paid to build buildings, and that's an important thing to remember. So any of the ones in yellow are in progress, the gray need to begin, and blue is complete. You can set this up in the field as well. So if you wanted to create a new one, sorry, gotta finish this off. So, okay, so he's going to record it. Now that one's done because he's pushed it to 100% complete. Therefore, it is done. So if you wanted to, you can set up another one in the field. Obviously, they wouldn't overlap, but you just set up some basic geometry, and with that, we capture some metrics. Again, this is set up back in the field, and then once it's saved, it all goes back to the server. So we're running out of time, so we'll jump over to the website. We won't have to set them all up. We put in pick lists to make it really simple, again, focusing on that ease of use. And then we have the website that we built. So we built the web server, the APIs, and the mobile app in the last day and a half to get this done. And so what we end up with is these are the work packages that are at risk. So based on the rate that is being completed in the field, you can see that this one here at 66.94% complete is at a velocity that means it will not make its targeted budget. So if you click on one of these cost codes here, what it does is it brings up, well, it's going to be off screen here, but brings up a burn down chart so that you can see that at the rate that you're going, you're not going to make it, and it also gives you down below a suggested increase in velocity so that you can go back into the field and talk to the people in the team and say, we need to either bring more people in, work faster, whatever it needs that has to happen. This will give you a clear view into that. So again, it's about the one tool, one problem, keep it simple so that it actually gets used and adopted, and that's it.
Awesome. Great video, by the way. Okay, so I don't know if the guys who are going up next are okay, awesome. So analyses. And are we good, sir? Yeah? Yeah? Okay. All right. Take it away, guys.
Cool. All right, I wanted to start with a question. How many people in the room are engineers? Hands up. And any kind of engineer. Okay, maybe about 25%. How many of those are building engineers? Okay, maybe about 3 or 4 people. So I got here on Friday, and I met a lot of architects and a lot of contractors, but not many engineers, building engineers. And I was actually a bit surprised because a lot of construction and a lot of creating buildings is about engineering and creating efficient details and creating buildable buildings. Contractors will know the minute they get a silly detail on site, it's costing them time and money. And anyway, so me and Chris here are both engineers. I'm a structural engineer by training. I actually work for a design build company, builds and designs and engineers timber structures, but, and Chris is a software engineer. But what we were thinking is, why don't we do, stand up and do a little bit about our trade, show what the engineering side of this whole web revolution might look like. So, next slide there. Oh, is that you? All right, wow, that's a big screen. Yeah, so in engineering and also in architecture, you need to do a lot of analysis in your building. You do building energy, thermal modeling, you do structural analysis, all sorts of different types of modeling. And one thing that often gets lost, these analyses can be very complex and take a lot of time to run. And there's no real nice ways of taking these different analyses at different points in time, comparing them, and really creating snapshots in time. The analysis packages that are out there generally only allow you to look at one particular instance in time. So our idea was to basically take results from many of these different analysis packages, chuck them on the web, use WebGL to view these things in 3D, and in that way, it basically enable various things. If you hit next slide. All right, so the first pain point we identified is there's many analysis packages. Next. If you just skip through the next few slides, it's just showing some of the different, there's many different packages that can be used for analysis. And just go back one slide. Yeah. This slide just shows, just from a structural engineering point of view, just maybe a third of the packages that are out there. And you can imagine when different engineers are trying to talk to each other or compare results or compare what they do, it's very difficult because there's no unified file format for like translating and comparing what this data or these models actually look like. The green grasshopper in the center, some of you may have heard of it, it's similar to Dynamo for Revit, but it's a visual programming language desktop based that allows you to, in some respects, connect these packages together. The only problem with that is that's done here on your computer, on your screen. No one else can really see it unless they have all the same software and all the same stuff you've written. So our idea was to kind of make that a bit more agnostic. Just next couple of slides. And basically put that on the web. The second pain point we identified is that often you're doing parameter studies. So you're looking at, okay, what if I make this building a little bit bigger or a bit smaller, or I change this column spacing, all this kind of stuff. And so you're wanting to know, how do these different changes in parameters impact the building? And you don't want to just see it one parameter at a time. You want to be able to see them all together and scroll through the different options, as it were, for your building. Next slide. Just go forward a couple. And another thing is, how do you look at changes in time? So this is looking at, for example, seismic analysis, where you're looking at a building moving. How do you capture that, and how do you show that to people who need to see it, to clients, or to especially here in the West Coast, seismic engineering is very important. So next. So people who are having these problems, primarily engineers, but also the people who we're trying to communicate these analyses to, architects and also building officials. Building, it's very important that buildings meet building code, and showing these analysis results to them is very important. Next slide. So one thing that engineers spend a lot of time doing is running these analyses, making printouts or whatever it is you do to capture what these the states of these different analyses and then kind of document their design process. But there's no real nice and easy way other than just saving multiple copies of same files to actually go back and view the state of these different analyses through the project. So, next. So as I said before, you can use Grasshopper in some respect to kind of use a slider and scrub through different solutions. But of course, not all analysis that you run for buildings, for example, daylighting analysis or thermal analysis runs instantaneously like that, so you can actually scrub through it. A lot of it takes a lot of time, takes maybe even hours to run. And so the idea here is to create a platform on the web which you can basically display your pre-baked analysis runs in. Next. So this is then just having a look at this here. So what we've done is using 3.js and socket.io basically connect an analysis package, which in this case happens to be structural analysis inside Grasshopper, into the web. Now, what you're seeing here is different iterations of this particular grid shell model and different states, different configurations, different density of grid, different size of elements, different force states in the elements. And all those solutions there, I literally, just while I was down here, pushed to the web. So this is stored in a web database. And so anybody who's running that software can literally push their analysis results from not just Grasshopper, but from any structural analysis package or building energy analysis package. I mean, we've used a structural example here, but this could very well be results of shadow analysis for a building or anything like that. And so the idea is that you can kind of scroll through your solutions or even display the solutions side by side, all your results, to enable a much more robust design strategy. And also you can provide a permalink to a design at a certain point in time so that it captures your thinking at that point in time, and you can go back to it at any point in the future. You can reference it in whatever calculations you might do, and provides a way of capturing it. So I mentioned briefly the tech stack we did. So this was all done in the last day, so right from scratch. Chris here managed to, you want to talk about it?
Yeah, sure. So there's two parts to it. There's one on the client side that looks at files that are exported by Grasshopper. It'll just look at all these files it's told to look at. If it sees this change, it'll post it to a service running Flask. It's a web development thing in Python. That's up on Heroku right now. And once it sees that, it will process that comma separated file and then inject it into, by using WebSockets, into the actual running display up there. So this is kind of an example right here where, actually we can try an export file if you want. We'll try a live demo on this one here.
So on my computer, I've got Grasshopper running, and I can change, for example, the density of the grid.
Yeah, these are previous ones. Oh my God, it worked.
There you go. Worked. So I changed the density of my grid, storing it straight to the server.
So what's nice about this is that I can view it on my browser. There's nothing special. It's HTML5. But he's got like a, well, I guess it's not really high-end, but it's whatever it is.
It's easy, yeah.
And I don't have that. So it's nice for him to change it. Like, he can change it again now we know it's going to work. So you should see it auto-magically update. There we go. He put some more meshes on there. So that's about it. All the code we have up on GitHub. It's open source. And it's 3JS was the web.
Yeah. So the key here is that previewing these analysis results is not using a custom plugin which is written for a particular piece of analysis software. All this front end is doing is parsing a bunch of CSV files, comma separated values. So this analysis could be coming from any software you like. It doesn't matter. It's completely agnostic, and all you need to do is write, slightly different front end code to parse that data. Maybe just hit next slide. Yeah, well, this is kind of what we've just been talking about, allowing, creating basically a solution agglomerator, as I was thinking of it, which allows you to really explore the solution space. Next slide. Yeah, one of the things that really struck me was that we were able to get this up and running in a day right from ground zero. Now, even just a year or two ago, this wouldn't have been possible. With open source libraries that are out there nowadays, you can really hack something together really, really quickly. And so there's no need to be tied to vendor-specific solutions necessarily, which won't necessarily talk to your particular package. You can really actually just hack your own thing, put this up on the web, open source, and anybody else can write their own link to their particular analysis package. Next slide. And yeah, that's it. Check it out on GitHub and let us know what you think. Add to it, please.
Great work, guys. Okay, so has Yard.
Amazing how effective a chair can be at bringing all your cords.
Oh, wow. Okay. Need a minute.
Yeah. It's our lean solution. Keith, I'm going to do your hand here. I'm going to be over here. I'm going to peel this
So again, don't forget to give your presentations to the people that are recording. And then also for those that have any open source code, please post that up on the Facebook group page to be shared. And we'll add that to the website.
Just like 2 minutes. A minute to get powered up.
Okay.
Cool.
So, Daniel, take it away.
All right. Is the SketchUp on? Yeah, it's launched. So just hit launch SketchUp. Hi, everybody. We're Hazyard. I'm Dan Shirkey. I'm with Balfour Beatty Construction. We're sister companies, or we work together with Howard S. Wright. I'm joined by Keith Walsh, who's with Balfour Beatty Construction, too. We're out of San Diego, and we teamed up with Iris VR and Nate and his team.
Very good. I'm Nate. I'm with Iris VR, and we're from Burlington, Vermont, so just sort of down the street here. And I'm working with Jack and Greg, and we were pretty excited to team up with these guys who know the industry well. So without further ado here.
Yeah. So we all met on, I think, Saturday morning, and we were throwing some ideas back and forth. And I brought a dev kit too, because I really wanted to start jumping into VR, and they are a VR company. And it was a very fortuitous meeting. And we said, what's one of the biggest pain points or issues or hot topics within the construction industry? And there's probably nothing closer to our hearts than safety within our industry. And so we thought we need to do something about safety and utilize VR to do so. So our idea was, let's bring the power of virtual reality to how we train people with regards to safety. And how we want to do that is we wanted to leverage the platform called SketchUp. Who's used SketchUp around here? Very commonly used within the construction industry for site logistics plans, bringing 3D models in a very simplistic way. And so what we'd like to do is they created a SketchUp plugin in which we could modify SketchUp models, that anybody could take this plugin and modify their SketchUp files and add in safe and unsafe conditions, mark them out on their job site, and then we could load it into their virtual reality platform in which they could view them and experience them in virtual reality. So here we are in a SketchUp model of a construction site, and if you go to Tools, Keith, and turn on the plugin, view toolbars, and it's called Hazard Constructor. And what we have here is a series of hazards. And so we've got a flag, which is for your job site trailer. In this case, we want to set a cement truck on the ground here, Keith. And you just drop it once, and then now we can move it around the job site. You could imagine loading a vehicle, and one of the important things is to not have people near the front and the back of the vehicle where its path of travel is. We could have a safe person on the job site by clicking a green hard hat, and it loads an avatar with improper personal protective equipment and a red hard hat. And so we wanted to load safe and unsafe people into the job site. And finally, let's go over to that trench near the center of the building, Keith. And let's make that an unsafe zone, which is that caution button right there. So it's a rectangular extrusion that comes across the surface. And when we go experience that in VR, you'll get to see what happens when you walk into unsafe places. So that, in a nutshell, is our SketchUp plugin. Will you go ahead and save that, Keith? And then let's just go ahead and create another file with just some quick dump trucks on it.
Okay.
And put it on that thumb drive next to your hand.
Sure.
Sure. So the idea here, sort of the idea with our software that we created and are working on up in Vermont is we want to make virtual reality accessible using the tools that you already use and are familiar with, right? So you don't have to learn Unity or learn a game engine, but an entirely new platform to have access to these great 3D VR and AR experiences that are coming out now. And that was sort of the driving force behind this project as well. We want to make virtual reality and the ability to create your own virtual worlds and virtual simulations to solve a very important problem, like creating a safety simulation or tutorial really accessible for anybody using SketchUp.
So Keith's just creating another file with like 2 jump trucks on it, and just save that as a dump truck, and then hand it over to
Do you want to talk a little bit about what your plugin beta does?
Sure. So in terms of the technology that's running, behind this, we have, thanks. The technology that's running behind this, the plugin is just a basic SketchUp plugin. And that takes a couple of pre-built models, and you can drag and drop them into any scene in any file. So this will work with any model for any job site that you have already. And then I'm going to pass the microphone off to our developers over here that did the front end.
Do you want to talk about yours?
Yeah, sure. So we decided to sort of take advantage of this beta application that we've already been working on, which takes the SketchUp file and brings that into our virtual reality environment. So we had to add the functionality of reading the new content created by these hazards, because these hazards aren't normal geometry, but they're special, and we want to let the user have more interactivity with them. So what I was working on was the go-between between SketchUp and the game engine that we're using, Unity. And so that was sort of using the SketchUp C API to read in these different hazards and write them in a way that they could be loaded into Unity.
Just taking
and lastly, I worked with, actually, once these hazards exist in our game engine in Unity, we wanted to gamify them so that it would be like a memorable experience that would allow people to go through the job site as if it were a video game and accomplish these different objectives. And really like remember, if you play a video game, you're going to remember like what works and what doesn't. And hopefully like this is more of an educational experience than simply reading a training manual or, more inconveniently having to go to the job site in person. Okay, there we go. All right, it's working. We're about to transfer it over and show you the next process.
Yeah, so I just wanted to give him a working truck model here, and I swear everything just works slower live. It's just how it happens. But what we're going to move into next is I'm going to wait to plug this in. What's up with this?
Let's get him plugged in over here.
Well, no, we already got the. We're going to do it on my machine. Hold on. All right. So what I'm going to do is I'm going to open up the. And of course my desktop moves around. Oh no, it's not it. There it is. Jeez. All right. So here we are. So I'm going to open up their build for their app. Sorry. And then I'm just going to pull up that SketchUp file for the building. And so what's happening here is it's loading in all the textures and whatnot for the building, and it's loading it into their VR plugin, and we need to turn on the Oculus Rift here. Sweet. That worked really well. Now he's got a load bar to his right, and it's loading in the model. You got that? He's got an Xbox 360 controller in front of him. And so one of the things we have to do every single time a new person steps onto our job site is we have to orient them to the project. And it's a very repetitive thing because we have hundreds and hundreds of new workers coming on our job site, and it's an important thing that we take seriously because conditions on the job site change constantly. Well, a lot of project teams already use Google SketchUp to simulate their site utilization plans for their buildings, so you can conceivably keep it up to date and load them into the latest virtual reality instance of their project and brief them on the site conditions without having to even expose an unsafe person to a busy job site. And you can also expose them to unique situations that might not be going on yet for a project, or even practice a maneuver that's going to occur on the job in virtual reality. So if you look around you, Keith, on the left, he's got a green zone, which is the evacuation zone for the project, and then there's even a cement truck there, and then to the right, as you keep turning to the right, you're going to see a job site trailer and also a guy with a hard hat. And so we're going to go over to that guy with the hard hat as soon as this is done loading, and it's going to talk about this mini game we created within the simulator, where as somebody's going through the job site, we wanted to not only make this a very good teaching experience for someone going through the job site, but we wanted to make it memorable and fun. And so as they go through the job site, they can point out people who aren't being safe, doing unsafe acts, or wearing proper protective equipment. And so we'll click on that guy. He's actually wearing everything he needs, so they're going to get a negative reaction from the system. And there's actually a scoreboard on the job site trailer. Typically, we put how many days we've gone without a lost time incident on a project. So we start with several hundred days, and then depending on how they perform, their days of safety go up, or if they perform negatively, they go down. So here Keith is going to approach the worker, and do we have the sound on?
Do we?
No, of course not. Here, just hit him. Go ahead. Okay.
The good news is you're fired.
So let's do it one more time, just so everybody captures it.
The good news is you're fired.
All right. So that's the negative treatment. They identified somebody that is safe, and then their score went down to 60 days, and it started from 100. So Keith, why don't you jump over? Or sorry, just jump all the way over to the project site. Just fly over this building. And you can see we have a crane there. You saw some of these features here. I'm going to go ahead and speed up the walk speed here and just go around to the front of the building. Turns out you can fly. We have jetpacks on our construction job sites. And so they'd be able to explore their job site, maybe some work to come on the project that they're actually going to be at part of that phase. And then we also have, continue past that edge of the building that you're at, we also can simulate things like when someone has engaged their fall arrest system on a project, they've fallen off the roof, they've activated their harness, but we want to time how long it takes for rescue personnel to get across the job site to where this person needs a jetpack to rescue them. And we can time them on how they get back. So someone's in the middle of their simulation, and they're going through identifying hard hats, and then they hear this. 3 horn blasts, that's something we should all be familiar with. That means evacuate the job site. Maybe there's a gas leak, anything like that. Then it's a race against time to navigate back to our muster point on the project. And he's frantically using the jet, engaging, and he's going to land like a paratrooper in the middle of a stadium onto that platform, and he hears a little trigger that says, safe. And if you do that within the time, you get positive score. And it's just a really powerful way that instead of just pointing at a map or walking over your site utilization plan in 2D to a craftsperson, we can let them experience that firsthand on the workspace that they're in and just test their retention of that knowledge in the VR environment. It's really exciting to think about how well they would enjoy this and then how well they'll experience that. You have it?
I think that's it.
Oh, no, we got one more instance
We got one
here.
more instance.
It's cool. It's totally worth it.
Oh, we need this. Do you have sound? I need the aux. Oh, yeah.
We don't need the...
Microphone?
Yeah. All right. So, 2 minutes? Oh, we're good. Well, if they're properly trained on the equipment, it's okay. It's the important part, though.
That's right. This is...
Did we lose it? Where'd it go? Is it on the other screen or something?
No, it's just connecting another monitor broke it.
Oh, you want to try unplugging and replugging?
So...
Let's just turn it around if it's still working. All right. Well, it's kind of heartbreaking.
That's kind of heartbreaking.
So what we're going to do is we're going to post the link on our website, and I'll post it to the Facebook page, and you all can actually download a build. You can download the SketchUp plugin. That's all open source, and we invite you to give this a try with a DK1 and soon to come a DK2 as well. So we'll put that up online, and you guys can build your own job sites.
Yeah. So anyway, what was going to happen is he was going to approach the dump truck, and Kenny Loggins' danger zone was going to come on to give them feedback that they are in fact in the danger zone, and they should call Kenny Loggins. But ultimately, let's make people safer using VR, and there's a lot of potential there, and thank you for your time.
All right. Curse of the live demo, but it's cool.
Gosh.
I blame it on my Oculus Rift that I gave them, guys. It was faulty hardware. All right, so up next we have OR Gate. Or Gate? Or Gate?
Which one is the big one? Oh my gosh.
Found it. Okay. Is this your stuff?
Yep.
No. Get out of your way. Whoa. That's just makes a second.
I don't think this one's quite right there. Oh, this is your dub. Okay, so we have the other team that we have up after these guys is Revit My Drone. And you're right there. But I think there was one other person, Lucky. You need to, you have a presentation as well? Okay, you didn't write your name down, so we're skipping you. No, I'm kidding, man. Okay, so we have 3 more presentations. And so I just ask if you guys can keep it under 10 minutes, if you can. And anyone else that didn't write their name down, is there anyone on deck? Okay, cool. So, whenever you guys are ready.
Awesome. Hi, everyone. My name is Oliver Carr. I'm a student over at Green River Community College, and with me, my fellow hackers, we have Matt Todd and Ruby Carrasco. We started out at Endeavor on trying to create sensors for the home. We wanted to create a base station with communications that can connect to a myriad of sensors and give the homeowners more information on what's going on with their house. What we started with for this weekend is we worked on this device here, which Matt has put together in a clever box which has an infrared sensor and a array of LED lights on it. And what this is allows us to put these sensors down underneath the house in our crawl space. We're also looking at putting this up in the attic space to detect and also deter critters that might be coming into our household. These are areas that humans usually just never are around and will never know what is going on inside their household. So by being able to put some devices like this, we'll be able to detect and have a human interaction with what can we do next. So either we need to find out which sensors were tripped, find out the entry point at which these critters were able to come into, and then also have an idea of, as a DIY person myself, be able to cover up the areas as well as pull away the attraction as why those critters were able to come over. We can also then contact wildlife specialists who can come in and also identify and extract those types of critters and give us more tips on how we can prevent it from happening in the future. Would you like to talk more about the device itself?
Okay, so our device, we first of all wanted to create something Arduino-based, so we were kind of trying to come up with the ideas on how to create something Arduino-based that would apply to the construction field. And so there may be similar pest control devices out there, but the advantage that this gets is we are able to log it, upload the logs, we can add GPS modules to where we could create a heat map on what areas are the most pest, which ones are setting off, what detectors are being set off most frequently so we could mitigate whatever problems we need. Every time that the sensor is tripped, we have a buzzer in here which is going off. It's buzzing at multiple ranges of frequencies which will deter range of different animals, a lot of different animals. We also have a short-range infrared sensor, which and long-range infrared sensors, depending on programming. We could program different distances to detect these
critters coming in, and then it can be hooked up via USB to get the serial output on the control screen, or go wireless up to 100 meters in length.
And so with the logging capability is what really sets the device apart from what else is on the market. Being able to connect the humans to their household and have a smart home. Thank you.
Awesome. Whoa. Yeah, do you want? No offense, Aaron, if we can save questions for afterwards, okay? Do you guys want to talk about any of the stuff that's up here?
These are the frequency ranges. These are the frequency ranges that animals respond to. Ours goes up, can go up to about 20,000 hertz with a European siren buzzer, which this is also capable of handling. It could go up to the 45 and 60,000 hertz. Also, when looking at nocturnal animals coming in, a lot of them are pestered by the strobing light effect, which is why we've added it in there. It's using infrared light, so it's versatile. It could be applied in any lighting conditions. It could be in a crawl space or attic, like he said, completely dark. It works under any lighting conditions. I don't know. That's kind of about all I got.
Yeah, that's fine.
Great. I love the fact that you put Blue Well on there. Okay. So up next is Brad. Revit my drone. All right.
Yeah, thank you. Yep. I'll have to go grab that.
You'll see. We have a video instead. We kind of broke it.
The YouTube video is playing it. Oh, I see.
We getting close?
Yeah.
Take it.
Hello? Okay, so my name is Brett Young. I run a BIM consulting shop out of San Francisco with offices in Portland and in District of Columbia called Modulus Consulting. I'm joined by Mark Decker, Paul Clausen, and Kai White. We're all BIM people. We're not professional programmers, so we're a collection of BIM professionals trying to do a system integration here. So we have a website, so you can check us out and look at how we've done what we've done. And we've produced a video that we can walk you through and talk about our project and show off the Revit API tied into the drone planning views.
Are we ready to roll the video?
Yeah.
We can just do that.
All right. Allow.
all down here. Can you get it? Okay.
Just do it from here.
Okay, so right with my drone, the building models we create are disconnected from reality. So the pain that we're trying to solve is connecting models to reality using drones. So at the heart of it, it is a Revit API hack that outputs to a drone planning software and ultimately to a drone. The reason we used this particular drone model is because it is hackable. It is all open source and can take in input files and then go fly them. Why are we using Revit? We use Revit every day. Revit is part of our workflow for BIM and is what we do our primary work products with it as professionals. So how did we do it? It's a pretty standard, you geo-reference your model, and then based on the coordinates, you do the math to get to lat long and elevation when you place a camera. So you go around the job and you place all these cameras that are in a space and they're looking in a particular direction. And then you can move them around. And you can look at what the model shows you when you do that camera view. You then go up and we put a button into our API for an add-in. And it outputs a text file. This is sample output and not the actual text file. But you can tell that when you start adding cameras to go look at your building, it gets very complicated very quickly because you're defining 2 points. You're defining the camera location and where it's looking at. And the combination of those 2 things are important. So there's our building. We modeled the building. It's right outside here in Revit, and you'll see more of it in a minute. Here's where we're outputting our text file through the API. And then it gets pulled into the drone planning software of the drone, the actual interface with the drone. So there's your text file. And you can see how complicated it is. I mean, it's not a simple thing. These are only 8 camera views. And it shows a very complicated view around the building. So the results, here's the Revit model of the building, the library book sale building. There's the actual drone photo. You can see more of it in action. This is a video showing the 4 corners of the building. The drone is entirely autonomous. There's no one touching and controlling it. It's being controlled by Revit. It wouldn't be a hack if we didn't have problems. We had a propeller fall off right about now. We put it in a tree, and special thanks for Damon for going up and retrieving it for us. So, and then now we're going to watch a trailer for Godzilla. So we'll post more of our videos. Actually, I can play it right now. The main thing that we have to, Carrie, if you can play the video 1, yeah, play this one. The one thing that we need to improve probably for the next hackathon is to do more about the pathways in between our viewpoints that we have, so that we can do clash detection in between the pathways and the things that we have in the building. You can see, for example, that we need clash detection of drones, yeah. But otherwise, try. We'll post it on the website, but basically it shows a drone going directly into a tree, which is really a... Yeah, it's an LOD problem because we hadn't actually modeled the tree. Sorry. Yeah, there's a tree. So anyway, so we're very proud of what we were able to achieve. We're not programmers. We didn't write any code before we got here. The drone arrived in the mail 10 days ago. We had never flown autonomous flights before we had gotten to the hackathon. So we're very proud of what we were able to achieve.
Great work, guys. My shirt has a battle scar. It's cool. All right, so, yeah, well, I have sap all over my body, actually. So it's all right, so up next. Yeah, actually, Lucky, you're up last, bringing us home. Yeah, exactly. Yeah, so just real quick as he gets set up, just a real quick round of applause for all of our volunteers that we had from, of course, the lady up there, Tarya, who helped with the coffee and all the food, and then, of course, the students, Mark, who's been awesome as we've learned from him how to use mice and break projectors and everything else, so this guy here was amazing, thank you. Of course, Carrie and all the sponsors and whatnot. So while he gets set up, I'll just make a real quick announcement. I will probably blast this internally because if I put it online, then everyone and their mother is going to have this. But thanks to a company called Volume, I hope I'm pronouncing that correctly, VULUME.com. They are giving everyone that's attending the hackathon here 2 years free subscription to their project collaboration tool. So check it out, that's kind of cool. And then thank you Autodesk for all the support of having people here. Also the really groovy t-shirts, so a round of applause please for Autodesk. And all right, Lucky, you ready?
Yeah.
Okay.
Good afternoon, everyone. My name is Lucky Pratama, and I'm about to present my research. And actually, it's not really a hack, but rather than an alternative for viewing construction sequence. I call it CSEC construction sequencer, and it doesn't have anything to do with CSEC and, medication. Next. So the basis for my research is when I was doing a 4D modeling in Navisworks, the model itself looks very simple. And I think it might be better if there's an alternative in viewing the construction sequence using virtual reality. So based on my experience, the errors in construction sequence may cause safety concerns and reworks in the construction sequence. And the problem is current 4D modeling software does not allow for direct interaction between users in the 4D model. Because as we know, that Navisworks or Synpro, we have to actually assign each objects or geometry within the 3D model into the construction schedule. And after that, you can only play the construction sequence forward or rewind the construction sequence without being able to actually interact with the construction. So after that, I have questions. What are the benefits of the implementation of virtual reality when reviewing a construction schedule? And which group of building element error is easier to identify in virtual reality? And what barriers will limit the application of virtual reality in reviewing the construction schedule? So the method for my research would be to test the validity of theory that is already available, which is virtual reality is good for reviewing construction. So in creating the 4D model, I create a 4D model with 3 types of construction sequence of errors in the construction sequence. First is the omission of an activity. Second is the illogical sequence. Or third is the duplication of activities. And how am I going to do that? I'm going to conduct an experiment using a virtual reality tool prototype, and then conduct surveys and interview to compare the results. So the data collection will be quantitative and qualitative, and I don't think I need to explain this too much. And yeah, this is not also important. And the development for the virtual reality tool, the first step I did was to determine which 4D model to use for the virtual reality, and then select which kind of hardware I would like to use, and next one, what kind of software I like to use, and then develop a prototype of virtual reality. So in generating the 4D model, there are two identical 4D models, and one model will contain multiple errors in the construction sequence. So in selecting the hardware, there are three alternatives. First is cave-like display, and I chose not to choose that because it's too expensive, and Google Cardboard, even though it is extremely cheap, but I don't know how to program at all. And then there is consumer-grade VR headset. It can be easily connected to PC with appropriate drivers. You can find the driver for Oculus Rift everywhere, and it is although more expensive than Cardboard, but it's still affordable, and it is compatible with most PC software. And in selecting the software, I chose to use video game software. There are three alternatives. First is Unity, UDK, and CryEngine. I chose CryEngine because it's very simple. You don't need to understand C#, C++, or any kind of programming language. And this is my workflow. First, I get a Revit model, and then I convert it to SketchUp, and then I convert that to CryEngine 3, and I have the schedule in Microsoft Project, and convert the schedule manually using visual scripting in CryEngine 3, and combine everything in the CryEngine with Oculus and an Xbox controller. I will show you. Oops. How it works. So what you're seeing right now is a blank work site with nothing. So using that workflow, I was able to recreate the 4D model within CryEngine. So you can see here the slab, and then there is the columns, and the walls, and the framings, and the second floor slab, and the stairs, and after that, framings for the second level. And actually, if there is an alternative mode where you can just fly around the construction site, which I don't think is working right now. Right. It's buggy, sorry. So the player will be able to choose to actually walk in the construction, or will be able to change their view into some kind of bird eye view or free camera in order to assess the construction sequence. And that's it for now. And actually, I've done some research, and I've tried it on my friends, and the result was not really good because there is no user interface at all, and there is no maps, and there is no markers whether the construction or whether the building elements is just built or which building element were just built. So, so far this is what I've done, and that's it. I'd like to thank you for your attention.
Awesome job, Lucky. Very awesome job. And he managed to work on that while helping out with us. So, all right. So, yeah. And so what we'll do now is I'll ask all the people who are judges to stay in this room. I'll ask anyone who would like to re-show us their demos to also stay in this room or bring their stuff in here. I will ask everyone else go in the other room because VRcade is going to entertain you guys with a nice presentation while we judge and decide, and then we will meet in that room over there to make the final announcements. Closing ceremony. Again, do want to start off with giving some acknowledgments. I think I forgot earlier. Greg deserves a huge round of applause for everything that he has done. He led the local team here, in addition to the sponsors, coordinated things with Carrie, who was also amazing. Again, everyone here. And do you have anything that you would like to say, Greg? Or?
Yeah, well, just quick before the prizes. Thank you for coming here on a sunny weekend in Seattle. I think I ask a lot of people, you're the people who chose to come, and I think that's also proof, you're the innovators, whether it's IT, VR, AR, or it's AEC, getting that community talking. You are it. Now we have that community, and I ask you to please stay in touch and grow that community, and hope to see you at another AEC Hackathon.
Okay, so as always, this is a very difficult thing to judge because everything that you guys did was pretty amazing. So I know people get tired of clapping. So for those that want to clap for yourselves, go ahead, but I think you all deserve a big round of applause, so I will clap for you, and so we have some prizes to give away. We had some different categories. It's a little bit odd in the way that the prizes are going to be dished out because of the different categories that we had. So I guess we'll just start with the, the first team that won the Hack Challenge for the best interactive 3D app that supported open source, open standards and whatnot is the group Analysis. Those guys in here? Yes? All right, so come on up. Woo!
$1 bill.
Oh.
Yeah.
You're gonna throw it up in the air?
It's raining in here, right? So.
All right, so I will put fight. No, awesome. Yeah, exactly. So congrats, guys. Awesome work. And a big thanks to our sponsors for covered that. So that's kind of the thing is we have different sponsors who cover different hacks, so that's why these are a little bit weird in the way that they're going down. But first place goes to Build Track. And, So not quite as much make it right, but there you go, guys. Awesome. Really good stuff. High five. They will find you, Michael. And then second place, we have the team from Dude, Where's My Nail Gun? Okay, that's awesome. Thank you, guys. Thank you. And then for the Autodesk Challenge, the best 3D application goes to the Avengers. So where are the Avengers? You guys win these lovely prizes here. How quickly the teams disintegrate. Okay. And then we have some other prizes for honorable mention. And again, these were people who kind of came together and did some pretty interesting things. These prizes are courtesy of our sponsors, Unreal, who makes the Unreal game engine. And so the first team, and so this is, again, another one of those things, 2 licenses to each of these teams. The first team is Hazyard. And you don't have to come up because I don't have licenses for you. So but just make sure that, yeah, exactly right. And this is where I'll say, just make sure to email Greg, and we'll make sure to get those guys. And then the next ones that get the license is Revit My Drone. Revit My Drone. I had no say in the judging of that, by the way, just even if I was in the tree. And then of course, our first time we've done this, but our first place student prize winner of an Unreal Engine license goes to Lucky with CSEC. So. Okay, so with that said, guys, thank you, everyone. This does conclude the AEC Hackathon 1.2, but please do join, the groups. Keep it going. We hope to see you at future ones. And as we've said in the past, if you guys want to go with what you built here, because, again, they were all awesome, please let us know. Let us know how we can help you, the community, get these out and whatnot. So thanks again, and we'll see you next time. Thanks.